So now let's wrap up this week's video with an example of using arrays and writing to spreadsheets and all these things that we have learned so far. Uh, so when you're building a LabView program in your lab, usually you want a data acquisition system to measure some signals for you and then send it to LabView, and then LabView will process those signals and give you print you the results of your instruments. So because here we don't have, I don't have a thermometer or some like pressure transducer or some transmitter to show you like data acquisition system in week, I guess week number 5. I will go to the lab and I will show you this kind of thing. But for now, we're just gonna use a random function that randomly generates numbers and assume that those numbers are some signals that your instrument or your hardware is giving to you. And then we're gonna play, in this example, we're gonna play with that random number as your signals. And I'm gonna show you like how you can build your array of data and run your system. So first thing first, go to the block diagram and then go to the numeric, and there is this random number function that produces random numbers from 0 to 1. So in this example, basically we are having a time which is somewhere between like 0 to 24 hours, and then we are having temperature from 0 to 100 degrees C, and we want to get these like time and temperature and then have an array or a matrices of the data, and then we're gonna save it into a spreadsheet. So do you choose 2 of these random functions? One is for time, one is for your temperature. And as I said, because we don't have a data acquisition system, we are using the random number as a signals that the LabView is receiving. So the first one is for time. So because it's somewhere between 0 to 1, I'm gonna multiply this number, which is from 0 to 1 to 24. And so I will have numbers that are randomly generated somewhere between 0 to 24 hours. And I will do the same thing for the temperature, but here I'm assuming that the temperature doesn't go above 100 degrees C. So that's why I'm gonna multiply it to 100. So now we are basically randomly generating time and a temperature here. Because because we're gonna run this program for a while, so we need a while loop until a certain constraint is met and the while loop finished and gets out. So that's why you right click, go to structures and then a while loop, and put the entire thing in a while loop. So what we have done so far basically is that we are having a while loop that is generating time, randomly time and temperature, and until a certain constraint which creates a control, a stop button is met, this while loop will run and operates and randomly generates a number. If I don't have this while loop and if I run this program, I will only have one random time and one random temperature. It's not going to do it several times. But with this while loop, I'm going to have it like this, like it will go over and over again. Let's create some indicator and see what this produce. So I will name this as like time and this one as of temperature. And now if I run this, you can see like how fast it is generating numbers. If you remember from previous examples and videos, if you want to slow it down, you can right click, go to timing, and then choose the wait function here, and then create a constant for a wait function until I need 1000 milliseconds or 1 second every time that this while loops operates. So from, I guess, the third video on LabView, I guess we were talking about it. I don't remember. But it was the first video we talked about a while loop. So if you don't have this wait function for time, this will operate really fast, as you can see. But if you have a wait function here, this while loop is going to operate every 1000 seconds, because it will come inside the while loop as the first iteration. This is the iteration number, and then generates the random number, wait 1000 seconds, and then go to the second iteration, and so on. So now let's see. You can see that we are producing like time and temperature randomly every 1 second. But we don't want to see anything like that. We basically want to see an array of data, so we can see time and temperature, and we can get this like rows of data that we save into an Excel file. So to do that, we have to build an array of our random numbers. So if you remember from previous video, if you right click, go to array, and then go choose the build array function, and then scroll it one row down. Basically, you will connect your element, your numeric number, to the first element, and for your second one, you're gonna connect this to the wall of the while loop. Again, if you remember from previous videos, we were talking about shift register in while loop. So this is the shift register example. You right click on this black square and say replace this with shift register, and then you connect the output or the appended array to the shift register. So what it means, that it will get the time here and then get it out into the while loop, and then use the second and put it inside here and underneath, and use the second time as it above. So basically it's gonna fill an array for you. So let's do this for the temperature too. So we go to array, build array, scroll it one item down, one row down, and connect the second element into the wall of the while loop, and then connect the output to here. So let's create some indicator for this. So we call this appended time, and we call this appended temperature. Appended time and appended temperature. So let's move things around, and you can see this is like one thick line, and from this 1 0 you'll see that this is a one-dimensional array. So this is for sure a one-dimensional array. I'm just gonna align them. Okay, so now let's run this. You can see how we are filling the rows. So the numbers that are generating in this iteration are going to be added to the previous iterations, and you will see an arrays of numbers. So I'm going to stop this. If I rerun it again, you can see that it didn't go back to 0, this array. It starts from the whatever that was left. Let's stop it again. So now you can see these arrays are filled. So if I run it again, they're not going to get empty and refilling again. They're going to be basically continue filling the array from the previous point. So look at this carefully. Like I run it again, and now it's going to refill it again down. So how can we solve this problem? You can see that initially when the while loop comes, we haven't added any like initial value to the array before the while loop begins. So that's why it gets the whatever that was previously stored. But if you stay in the shift register icon here and say create a constant, and the constant by default is gonna be 0. So basically what happens is that let me show you this. What happened is that it's gonna at first it's gonna come at 0, so it's gonna make this array zeros. and come here, and this random number is going to generate some time, and this is also 0, so then this number and 0 are going to get together, and the first row is going to get filled, and then the results of it going to get out, but this time it's not going to read 0 again. This 0 is only for initial, but it's going to read whatever that was from previous step or previous iteration. And in the next iteration, it's going to keep whatever that was in the previous iteration as this 1D array, and it's going to add a second element or numeric to that 1D array and continue having another 1D array and so on. So now let's run this, and you can notice how this is going to get 0 and new numbers are going to get filled. See, now it's zeroed and new numbers are filling. So if I stop and then run it again, just see how it's going to get 0 and then run again. So shift register is really helpful with while loop, and just use it's really helpful to always initialize your array. In this case, you want to initialize it to 0. For some specific problems you might have, you don't want to initialize it to 0. You want to initialize it to some other numbers. So just remember that this is really helpful. And shift register is also really helpful with the build array function to have an array of data rather than just some constant, like some numerics. So next step, we are creating time and temperature, but they are like, this time is weird. It's not ordered, like 17 hours, then 18 hours, then 1 hour. So it doesn't look basically ordered to you, and you want to usually have time from like 0 to 24. You don't want it to be like randomly scattered. So if you come here and then right click, go to array, there is a function that says sort 1D array. So it's going to sort it from a smaller number to the larger number. So you can choose that here, and basically I'm going to delete these lines. And after you've built your array, you want to sort it, and then you want to send it to the next step. So it's gonna create a random number, put it into an array, sort the array, and send it back to the next step. I'm not gonna do it for the temperature because I'm just assuming whatever. It's just because the temperature doesn't need to be sorted. I just want to sort this for time. So now let's see how it works. So it's just, you can see it created 17 first, but then it was 7. So it's just sorting the numbers and then changing them. As I said, this is not a real situation. In the real situation, you will have a real time and a real temperature. You don't have to sort it. But for this case, because I want to show you something that you might see in your program, I'm just using randomly generated numbers. But I want it to be sorted, so when you're looking at the time, it doesn't look weird, but it's like follows the time. But it might not necessarily correspond to the correct temperature. It's just some random numbers. So when we go to the data acquisition problems, then the time and whatever measurements you're reading are corresponding to each other, and they are okay. So let's stop this. So for the next step, what I wanted to do is this. I want to get these two 1D arrays into one matrix, and then use that matrix to be saved in an Excel file. So let's get started on that. I'm gonna move this here a little so we have everything in the middle. Okay, so if you right click in the array and then this time go to matrix, there's also a function called build a matrix. You can also build an array, doesn't matter, but here for this experiment, for this example, I just wanted to show you one function of matrix 2. So choose the build a matrix and then scroll it one row down, because you need two elements to be added to build a matrix. The first one is the time, and the second one is the temperature. And then you're gonna create an indicator and We're gonna name this as time slash temperature, something like that. Notice how this line is different. You can see it's like dashed lines and it's thick. So this is showing that you are having a matrix. And again, a matrix here, it has rows and columns, and you can move it around and change it and all these different things that you want to do. So I'm gonna bring it one level up, and I'm gonna move these things. Okay, so now if I run this problem one more time, this exercise one more time, you'll see how this is creating your data. Like time and the temperature. I'm gonna stop this as in one matrix. You can see like how like time and temperature, they are all showing here. Like 16.58 corresponds to 11.43 degrees C. This is just so random, as I said, random numbers generating. And now I have a matrix of data of my time, or of the temperature that I'm recording over time. So now let's say that instead of like a user manually stop the program, you want to tell the program to stop the program whenever the temperature is above 80 degrees C. So for some specific problem, you don't want your instrument to start heating up and go over 80 degrees C, but you want the instrument to stop and don't run higher than that. So then you have to tell the LabView to stop the program or stop the heating up procedure whenever the temperature is above 80. So instead of like having a stop button, you want to have a different constraint. So I'm going to delete this stop control here, and I'm going to move this stop icon above here, somewhere around here, and I'm gonna say I need a comparison, right? So I'll go to the comparison function, and I say if my temperature is greater than 80 degrees C, then stop the program. So I'm gonna just use this temperature, which is just the temperature that is generating the numeric temperature, not the array, because I'm just gonna compare the temperature that at each step my thermometer is measuring. Is it over 80 degrees C or not? If it's below 80 degrees C, continue with the next iteration of generating temperature and reading the temperature. But if it is above 80 degrees C, just stop the while loop. So I connected this comparison, which is either true or false, to the stop of the loop condition, which is the stop here. So now if the temperature is above 80 degrees C, this program stops. Now I'm going to run it again, and it's going to randomly generate some temperature. I don't know when it will generate 80. It might generate at the first iteration or at 100 iteration. I don't know. Let's see how it works. Oh, it's generated at the second iteration, so you saw it stopped. I will do it one more time. Hopefully it will take a while for this one. So it's continuously reading temperature until it reads temperature of 90 degrees C, and then it stopped. As I said, notice that the 90 degrees C happened at 0.5 hours. As I said, because this is randomly generating number. You can do the sorting thing for the temperature too, so that doesn't look like that. But don't mind this, because this is not real. I'm just randomly generating time and temperature. Just what is important is the other part of the program. This was also something that I really wanted to show you about, like stopping a while loop with some conditions that you define for your project. So next step, let's say that you want to save your matrix that you're building here into an Excel file and into a specific folder in your computer. If you remember from previous videos, you go to the file and then you choose the right delimited spreadsheet and bring it here. If you want to, you can just easily write the temperature and time into the spreadsheet, but you will not create labels. You wouldn't know what is the first column or what is the second column. I personally think it will be really nice if we have labels for our columns too. So that's better to create labels. And labels, because they are time and temperature, they are strings, they are not number. We have to define an array of string first. So you right click, go to array, and array constant, choose an array constant. But then you have to define that this array constant is a string. So you right click again, this time you go to string and choose a string constant and put it inside. Now we know that this array is a 1D array of string. You can drag it one level to the right and then make it larger, and you can say this is time, the first one, and the second one is my temperature. So now this is going to basically be my labels. But how can I connect the label and the time into the right delimited function? It's not possible. This one either accepts numeric or strings. So how can we do that? I think the best way to do it is to change these numbers into a string too. So we will have everything as a string and then write it to an Excel file. To do that, you have to right click and go to the string function. There is another function inside which is called number to string conversion. And once you are here, choose number to fractional string, because your string has like decimal points. It's not just 1, 2, or 3. It's like 1.34 something. So choose number to fractional strings and put it here. So now, if you get your matrix connected to the number here, you can change with the precision. Here the precision is 6. It might be enough, but I can increase it to 10. So 10 means like 10 spots. So if your number has like 10 spots, it should completely fill it. And for example, here my number here is 96 point something, is 1, 2, 3, 4, 5, 6. I guess. Let me increase it so we can see it better. So here is 1, 2, 3, 4, 5, 6, 7 spots. So 7 spots, for example, for 96.0599 is enough. I chose 10 to make sure that I have enough. And now I'll have a string here for my time and temperature. And I also have another string for my labels. So it will be really nice if I can build all these strings into one array. So again, how we do it, we go to array, we choose build array here, and the first icon is going to be my labels, because I want to see my labels first and then the numbers. And the second one is going to be the number that we just created. So now I'm going to have a string array that has time and temperature on the top of each column, with the numbers, which are now a string, underneath them. And I'm going to transfer this into my 2D data node for the Excel to be written in. And then for the file path, you go and create a control, which is going to be where you want to save your Excel file. So you have to define it. I'm going to move things here a little. And then I have to define the delimited to be a comma, very important. And the format is going to be %s as a default, which means that this is a string. And then error out is really important to create an indicator for the error out. And yeah, I guess this is ready to be run. So I'm gonna choose a path for where I want to save the data, and I'm gonna call it like data5.png. be sure CSV, be sure that this is a CSV because this is a text file. And now I'm gonna run it. Let's see. Everything gets 0. I'm producing time, which is sorted. I'm producing temperature. I'm combining them to each other, and then whenever the temperature is above 80, the program stops, which is just stop. And now I have to have an Excel file that saved my data. And I don't have any error here. That means that the file has to be saved. So yeah, data 5. I'm gonna open this. See? I'm having time and temperature, and exactly these numbers are being saved here exactly. And 10 was enough, 10 as the precision, because yeah, you can see it printed a lot of numbers, like 1, 2, 3, 4, 5, 6, 7, 8, and then there's like let me show it to you. So here you can see there's like 2 space on the back of 94. That means that because I said 10, it put 10 2 more spaces before 9. If I chose 8, it won't do that, and it would be just enough. I'm gonna run this one more time, but before that I'm gonna delete this data number 5. Okay, I have to delete it from here. Yeah. And this time, instead of precision 10, I'm gonna go with 3, and you see the difference here. I'm gonna run it one more time, wait for it to get to 80, the program stops, and I'll open the data number 5. And this is what you see. I made some mistakes here. So the precision is a decimal points here, and I chose 3 for this run, and you can see the decimal points are like 3 here. So that's the precision. So before, when I chose 10, it means that I had enough, like way more than enough for the precision point of the decimals, like the number of decimal points here. So that's the precision. But there's also another thing here, which is called width. And if you go and then create a constant for it, it's right now it's at 0. So if I go, for example, with like a 6 or something, and now if I run it one more time, this width is the number of spots in your Excel file, and the precision is the number of decimal points. Try again. Let's run it one more time. Just waiting for it to get to 80. Okay, it's done. Now open it. We have to have 5 spots and with 3 decimal points. And you can see like I'm having like the space before that is like 1, 2, 3, 4, 5, and then 3 decimal points here. So if you go to the help here, it basically shows you exactly what this width and all these things means, the precision. So for example, if you type width 6 with precision 2 for this number, it's gonna say 1, 2, 3, 4, 5, 6. So overall 6 spots here with 2 like decimal points here. And like for example, for this one, 8 and 4 precision point is gonna choose the 4 decimal points here, and it's gonna add enough space until there is like 8 spots there. This is exactly what the width and precision here, they each one of them they does. So I think this example is like really helpful for you guys, because when you build your project to run with LabView, you're going to use these a lot to append array and then add them together and keep a matrix and then write it into an Excel file and run it over and over and over until a certain constraint that you have is met. I hope this was really helpful, and will be helpful for you in your future research and project. I think we are done for this week. In this week, I've talked about clusters, arrays, and how to debug a program and how to make a sub VI. We will continue with graphs and time loops and so on in the next video. See you soon.